I'm Liubov Volk. I'm Associate Professor of National University of Water and Environmental Engineering, Rivne, Ukraine. The influence of deep pollution on the ecological and melioration state of draining mineral soils. The current problems of energy, water, and food crisis, as well as climate changes, determine the need to implement appropriate adaptive measures to improve the ecological and reclamation state of draining mineral soils. In the zone of drainage reclamation, this is possible based on the development and adaptive complex, including agro-reclamation measures. They are aimed at an effective regulation of water regime, regulation and accumulation of moisture in the soil profile and within the system, and improvement of technologies and means of deep soil loosening according to the energy efficient and resource saving principles. They will make it possible to effectively accumulate moisture in the soil profile on the massive to be drained, to increase its moisture supply. Research methodology. For a comparative evaluation of various variants application effectiveness of draining mineral soils, deep pollution on the representative object for the condition of the western Odessa, Ukraine. Experimental study was carried out. According to the obtained experimental results, predictive calculations were made based on the use of an appropriate complex forecasting and simulation models, which includes a local climate model, water regime models, and water regulation technologies of draining inlets. A model of the development and formation of crop, which are implemented on the basis of long-term forecast. For an approximate assessment of the research measures ecological sustainability, ecological reliability factors, consideration of their operation, and to maintain favorable natural and reclamation and soil regimes within the project period. It is necessary to calculate function ecological reliability coefficient of the reclamation system. The ecologically optimal option is considered to be the one for which ecological reliability coefficient in the interval of values 0.5 to 1. In addition, ecological reliability coefficient indirectly reflects the ecological and melioration state of draining mineral soils. Once the basis of the research generalization was scientifically substantiated, the need to possibility through the improve energy efficient and moisture regulating technologies and technical means of deep pollution to influence the improvement of technical, technological, and use economic efficiency of draining mineral soils. Deep pollution changes the macrostructure of draining mineral soils and affects the macroaggregate state of soil, their density and porosity, water physical properties, and accordingly the ecological and melioration state of draining mineral soils, and the condition for the development of cultivated crops. To ensure the implementation of the necessary improvement of deep pollution for modern conditions and requirements, a transition from the traditional widely used check and strip pollution technologies to continuous layer by layer deep pollution of the soil differentiated by the is proposed. This soil loosening method can be improved according to energy efficient and moisture regulation principles and according to tiered technical means. The improved technologies and means of deep continuous loosening made it possible to improve the structure of the soil, which is development and each corrosion layer by layer. At the same time, it makes it possible to differential the value of its loosening by depth of up to 0.6 meters. The proposed design of deep loosening and improved loosening is presented on this slide. Comparative field production tests of various technologies and means of deep loosening were performed at the facility of the private agriculture enterprise Myrne in the Kostopil district of Rivne region, Ukraine, on an area of 25 hectares. Table 1 presents a generalized comparative characteristic of values of the main indicators of water physical properties in the 0.6 meters soil layer averaged over time by the after effect period and plan by the soil profile and by different types and variants of its loosening. The term of effective technologies after effect of the considered methods of deep loosening of draining mineral soils was crack soil loosening 1 year, strip soil loosening 3 years, continuous soil loosening up to 4 years. Table 2 presents a generalized comparative characteristic of the average values of the main agroamelioration indicators of layer of loosened soil with a change in supply of productive moisture and according to the most universal indicator of cultivated crops productivity of variance of its loosening. Table 3 shows the comparative efficiency of using different variants of deep loosening of drained mineral soils according to the result of field experiments. The obtained result of harvest of cultivated crops adequately describes the achieved indicator of improvement of their growing conditions and ensures their increase on average according to the option of deep loosening of draining mineral soils. Crack loosening of the soil 5 to 10%. Strip loosening of the soil from 10 to 20%. Continuous loosening of the soil improved from 20 to 35%. The results of the analysis show that the method of continuous loosening of the soil provides a greater increase in the yield of cultivated crop than with the crack or strip loosening of the soil. This not only compensate of the cost of its implementation, but also creates a profit. The summarized results of determine the economic efficiency of investments in the reconstruction and modernization drainage system using various technologies and means of deep loosening according to the appropriate methods and models are presented in Table 4. Thus, all considered technologies of deep loosening of the soil are profitable and economically beneficial. At the same time, the most economically and ecologically effective and the proved continuous deep loosening of the soil. All conclusions are presented on this slide. Thank you very much for attention.